Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the project you hear about on the show, you'll need somewhere to deploy it. So check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. And if you need global distribution, they've got that covered too with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode, today to get a $20 credit and launch a new server in under a minute. Alluxio is an open-source distributed data orchestration layer that makes it easier to scale your compute and your storage independently. By transparently pulling data from underlying silos, Alluxio unlocks the value of your data and allows for modern computation-intensive workloads to become truly elastic for the cloud. With Alluxio, companies like Barclays, JD.com, Tencent, and 2 Sigma can manage data efficiently, accelerate business analytics, and ease the adoption of any cloud. Go to dataengineeringpodcast.com/Alluxio, that's ALLUXIO, today to learn more and thank them for their support. And understanding how your customers are using your product is critical for businesses of any size. To make it easier for startups to focus on delivering useful features, Segment offers a flexible and reliable data infrastructure for your customer analytics and custom events. You only need to maintain one integration to instrument your code and get a future-proof way to send data to over 250 services with the flip of a switch. Not only does it free up your engineers' time, it lets your business users decide what data they want where. Go to dataengineeringpodcast.com/segmentio today to sign up for their startup plan and get $25,000 in segment credits and $1 million in free software for marketing and analytics companies like AWS, Google, and Intercom. On top of that, you'll get access to Analytics Academy for the educational resources you need to become an expert in data analytics for measuring product market fit. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference. Go to dataengineeringpodcast.com/conferences to learn more and take advantage of our partner discounts when you register. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And please help other people find the show by leaving a review on iTunes and telling your friends and coworkers. Your host is Tobias Macy, and today I'm interviewing Tamal Saha about KubeDB, a project focused on making running production-grade databases easy on Kubernetes. So, Tamal, could you start by introducing yourself?
Hey, I'm Tamal. Glad to talk to you today. Yeah, so I'm a software engineer by profession. I'm the founder of the company called AppsCode, who's the primary sponsor behind the project KubeDB. So I was born and raised in Bangladesh. I came to US as a PhD student. So after finishing my master's, I did spend my time working at Amazon for a short period, and then I worked at Google for around 3.5 years. And then I started the company around 2.5 years ago. So that's sort of short background on myself.
And do you remember how you first got involved in the area of data management?
Yeah, so when we started the company, we were trying to do something we would call like a integrated development platform. You can think of it as like a Google Apps for developer tooling. Like if you sign up for Google Apps, with a single sign up, you get your Gmail, Drive, calendar, all kinds of applications. So if you think of doing software development, like you need something like a GitHub, then some sort of CI/CD, maybe Jenkins, and then some way to deploy that application, and then like have a monitoring and all that. And we wanted to build a platform that kind of do all those things, sort of as maybe take some of the existing open source stuff and kind of glue them together as a platform. So we started doing that, and we were trying to build that platform on top of Kubernetes in 2016. And after spending quite a bit of time trying to do that, we came to realize that there are like a lot of limitations, or sort of you can say gaps in what the upstream Kubernetes project provides. And one of the key areas was the data management. One of the things that we noticed is once you start running some of your applications on Kubernetes, It is much easier if you can run everything on Kubernetes, because then otherwise you have to kind of maintaining two separate stacks, especially if it is a sort of a, like greenfield project that you are developing. You don't want to have multiple stacks. So we started using Kubernetes, and then we found that, like, if you if you one of the key areas is like if you want to run a database, or if you have a some sort of system, or like for example like if you're Jenkins where you store data on the local disk, how do you back that up, like how you make sure the database fails over and all that. And as sort of we started like kind of struggled with our own initial project idea, we eventually we kind of started to seeing this gap in the Kubernetes space and started doing like building some tooling around just managing these databases on Kubernetes just for ourselves. And that's how we got started. And then at some point we open sourced it in early 2017, and since then we have been seeing a lot of like interest from people in the community, in the open source community, and we have been kind of continuing to develop that as Kubernetes develops.
And so you've given a bit of an explanation about what KubeDB is and how it got started. And I'm wondering if you can talk a bit more about the main challenges that exist when trying to run stateful systems on top of Kubernetes.
Yeah, so the one of the interesting challenges with Kubernetes is that it's a very dynamic environment. Like if you think about a pre-Kubernetes world, like if you had a small setup, you probably were just deploying manually, maybe with some shell scripts and things like that. And then if you're a large deployment, you would probably use some sort of configuration management software like Chef, Puppet, to essentially bring up VMs with software stack pre-installed. And the general expectations is that those VMs will keep running as long as unless you as a, like the SRE or the DevOps for the system decide to move things over. Even if the cloud provider, or if you are on a on-prem, I suppose your whatever system you are using to manage like an OpenStack, if you have a issue, the system will go down, but it will stay there, and then you have to do the manual move recovery. Or in case of cloud provider, it can move over to a different VM, but it stays there on that, like on the data, the local disk, and the data stays there. Now, in the what happens in the Kubernetes world is that when you are running these containers, which is called pods, which is essentially like a collection of containers with the same namespace. So what happens is that if something goes down, Kubernetes is intelligent. It is a self-healing system. What that means that it will go and basically move that pod onto a different node. And then if you are on a if you have the on a cloud provider where the storage can be moved, it will actually move the storage and restart the pod, which is great, because if you have a stateless system, then this is all you really need, because if your pod moves over, it restarts, you're good. But if you're in a stateful system, one of the challenges is that most of the stateful systems are not sort of designed to work in this kind of really dynamic environment. So one of the things that happens in this dynamic environment is that the IP address changes. When the Kubernetes pod restarts on a different node, or even on the same node, it is not going to have the same IP. Many of the existing like databases, like think of Redis or Postgres, they use the IP address of the host or the pod, in this case, in case of Kubernetes, as the identity of that replica of that database. So what you need to do, they like if you are running a stateful application, even if you use Kubernetes has a concept called a stateful set, which guarantees a static host name, but the IP address still changes. So you need some additional like tooling around your like this stateful applications, like example databases, to make sure that when the pod comes back up, it is again correctly connected back to the cluster, like whether it's still a primary or it's a sort of like a follower or like a secondary machine. Those are the one of the things. And then the other thing is, if you are really using a stateful application for production use case, you want to make sure those are properly like backed up in a periodic schedule. If the database supports like streaming backup, like in case of like a Postgres, you can back up wall files, things like that. Those are properly done, and then you have a way to recover those in case of a disaster scenario. You can recover back from those backups. So those also are not really directly supported by the upstream project. Upstream project provides us the sort of the constructs and the the basic feature necessary to implement those things, but those has to be done by whoever is running a stateful application on top of Kubernetes. So those are the challenges that people usually like developers using Kubernetes, running stateful applications on Kubernetes face, and KubeDB is really addresses that aspect of running production workloads, production stateful databases on Kubernetes.
And you mentioned that one of the reasons for wanting to be able to run the database on Kubernetes as opposed to just running it as a dedicated instance or via some managed hosting is for having it use the same sort of life cycles as your development and same sort of deployment tooling. But I'm wondering if there are any benefits to having it just be a hosted instance and just have it live outside of the Kubernetes environment and be able to just manage the application as a separate entity, and any of the real benefits of having the database is as part of the same Kubernetes platform.
So one of the things that you just mentioned, like obviously the benefit is the sort of same stack which comes with all your like monitoring, all your alert management. Like if you're using Prometheus for your monitoring, those can all, you can have a like common view or one single called the single pane of glass view of your entire production infrastructure. So that is definitely a big benefit. And then depends on where you are running your workloads. Like if you are on-prem, like you are running like on a bare metal cluster or maybe with OpenStack, and you are using VM, Kubernetes to run your workloads, there you do not usually have the benefit of a hosted service. I mean, if you are on like a cloud provider, then yes, you do have that option of using one of their hosted services. So we see a lot of users who are like on various reasons on bare metal or like on-prem Kubernetes clusters. They need something like KubeDB to sort of operate and manage their databases. So that is one use case. The other benefit with running like databases on Kubernetes is that some of these cloud vendors, if you actually look at their managed offering, their managed database offering usually don't have the latest version. Sometimes they are quite a bit behind from whatever like was the latest version of the database. And if you have an application use case where you actually want to use the latest version, then if you are running on Kubernetes, you can essentially get the latest Docker image. With KubeDB you are able to do that. So that is another benefit that we see. And then the other benefit is like if you look at the pricing model on the cloud providers, that is I believe one of the, like we recently did a survey of our KubeDB users like a couple of months ago in February. And one of the things that we saw why people are using, like even when they are on public cloud, running the databases on Kubernetes is because it is much cheaper. Like if you are on, let's say, AWS and using their managed Elasticsearch solution, and you say you are running a 3-node Elasticsearch cluster with the M4 large or X large, we did some like sort of calculation recently. Like they are charging over, like if you are on a purely on-demand instance for a 3-node cluster, they are charging an extra $2,500 for per 3-node Kubernetes Elasticsearch cluster. So if you are on Kubernetes, the benefit is that you only pay for the VM and the disk space, but you are not really paying anything extra, not at least in monetary terms, for the managed layer. If you think in terms of the managed service when the cloud providers offer, they are not really being your DBA, right? All they are making sure that your database is running, it is properly backed up, and if you need to recover or restore, there is a way to do it. And all those things can be done using this operator pattern on Kubernetes. That's what we are doing with KubeDB. And if you imagine in a world where our like KubeDB is still quite a bit hardened at this point after the like last 2 years of development, but you can imagine that at some point you can get the same quality of service when you are running the databases on Kubernetes, and you don't have to pay for that extra money. So a lot of the people who are cost conscious, we do see them using Kubernetes, like running databases on Kubernetes using KubeDB. In fact, the survey that we ran, one of the interesting sort of stats was that it's not like so. We saw that people using multiple ways of running databases. So, like we saw that 31% people say they are using cloud providers managed solution, and then 43% say that they are doing like a self-hosting, essentially running it outside Kubernetes in some fashion. And then there was a 45% people who say that they are using Helm charts, just directly Helm charts to running databases before they were using Kubernetes. Those are the numbers. So obviously this is more than 100%. So people are using multiple ways of running databases as they figure out how their Kubernetes transition happens.
And so, can you describe how KubeDB itself is implemented and how it has evolved since you first began working on it?
Yeah, so Kubernetes, has evolved a lot, and at the same way, KubeDB has evolved alongside. So KubeDB right now is implemented as a collection of CRDs, which is called the custom resource definitions. So and an operator for each database. So if you're familiar with the way Kubernetes works, is that you have the Kubernetes API server, and there you can define or register like custom resource types. It's kind of the same resource type if you think in terms of like a REST API server. You have a resource you can define, and those resources for KubeDB, we have defined this number of resources, each one for each type of database, like Postgres, Mongo, MySQL, all of that. And then what happens is that we have written this operator. So one of the interesting thing about Kubernetes is that it will kind of give you like a push notification kind of concept. It's called watch in terms of the Kubernetes lingo, but it's like a push notification you get like on your mobile phone if something on that resource changes, and then you can write a reactive code. It's like a control loop that will take actions as needed. So the way it works is that user goes and creates so deploys this operator in the cluster as a deployment, and then they can say, okay, I want a Postgres database with clustering, maybe one master and two replica, and this version of the database, and this much CPU memory for each node, etc. Then they will create that resource definition, and once they create the definition, our operator will get a push kind of notification, like a watch notification, that a new resource has been created, and then it finds out that the necessary things that it needs to do, like essentially it needs to start a pod, it needs to create, issue those storage space needed for those database are not there currently. So it will actually create those resources as another resource in the Kubernetes context. And then those controller for those, or the operator for those resources, will sort of provision the database. And then once all of those aspects are ready, like the database is ready for the user, we'll get back to the user saying that, hey, your the resource that you created now is status ready, so you can start using that with your application. So that's sort of the general model that we follow, and right now we have a separate operator for each database that we support. So we support Postgres, Elasticsearch, MongoDB, MySQL, Redis, and Memcache. And so those are the sort of the common databases that we see a lot of requests for. And there is an operator for each one of them. But then for the user, we kind of combine them all into a single Docker image, like a single Go binary, and then as a Docker image, and deploy that onto Kubernetes.
And how has the development cycle of Kubernetes and the overall velocity of the project impacted your ability to be able to build and support KubeDB? And I'm also curious about how some of the relatively recent features, such as stateful sets, factor into the ways that you're able to leverage existing primitives in Kubernetes rather than having to implement them on your own.
Yeah, so when we actually started the project, like back in 2016, like early 2016, we're actually didn't even using any of these concepts. There was no concept of CRD. There used to be something called like a TPR, or third-party resource. So when we originally started the project, we were essentially building our like own regular, just a standard HTTP server. And if you make a request to that, it will run the Kubernetes pods as a deployment, and that was like our really like a version 0.1.0. And then we became familiar with the concept of TPR. Then we sort of switched to that. Even then, around I believe around 1.5 or 1.6, Kubernetes 1.5 or Kubernetes 1.6 release, they released this concept of pet set first, and then they renamed that to stateful set. I believe it is around 1.6. And at that point, we switched over from deployment to stateful set. This was a pretty important development for running stateful applications on Kubernetes, because stateful sets does a couple of important things. One is that you can essentially give it a static host name, which is useful in certain context. And the other issue is that with this stateful set, it guarantees that the number of replicas you want, the Kubernetes will never create more than those number of replicas. So for example, like if you are doing a deployment, and let's say you say I have 3 replicas, and you decide to change the Docker image tag, it will actually create a new instance. You will create like a new replica with the new image tag. So for momentarily, your number of replicas will go up to 4, or you can actually control how fast, like how quickly it switches over. So, but at least it will go to 4 at first, and then it will kind of kill one of the old pods, and then essentially kind of do this rolling updates. But if you are running, I think if you are running like a database, you usually don't want that kind of like a increase in the number of replica size, because you want your replica to be either like a, if you, especially in a clustered scenario, like 1 or 3 or 5, not like a go to 4, even for momentarily scenario. So there are those sort of challenges which are actually addressed by stateful set, especially if you are like switching over or like an updating image tags. So that was pretty important. And then the other important development that happened in the Kubernetes space was the TPR concept that was originally introduced was kind of really like an alpha feature. And since then, like there has been a lot of interest in the Kubernetes community building this kind of applications for Kubernetes. And as a result, the upstream project introduced like a new version of this, which is called the CRD, the custom resource definition. And then that has actually like evolved a lot and has been improving with every release. I mean, I would say like just up to the last December, when the Kubernetes 1.13 was released, they introduced some concept called like a version conversion in your CRD. So if you think of this way, like you say, we talked about this thing, like we have this YAML version where you decide how you want to specify the desired database configuration. But let's say at some point we find out that okay, we need to change the format of that that YAML object. And before 1.13, there was no sort of way to do that migration automatically. Like all you really had to do was kind of like a shut down your apart or do the migration manually, and then kind of bring it back. And if you think in terms of like a production quality system, that is not really a great scenario or user experience. So those things have been addressed now. So all those improvements in the CRD by the upstream project has been really essential to getting KubeDB to a point where we are very comfortable with saying that it is production ready, if people are willing to use it for production quality databases.
And so you've described how KubeDB enables you to be able to deploy these different database engines and get them configured. And I'm wondering, what are some of the other aspects of the overall lifecycle of the database that it simplifies and sort of takes out of having to be something that it gets set up upfront that is just somewhat automated by using KubeDB versus doing it manually?
Sure. So, I mean, one of the first things that we have tried to address was that just running a database, bringing up a database with as few bits of like information from the user. So, all we really want from the user to tell us that, okay, I want to run the Postgres database or Elasticsearch database, maybe this version, and this many replicas, or maybe like one master, two replica, whatever it depends on the database type. So the first issue, the pain point that we address is, given just that little bit of information, we can create all the rest, which is like all like creating the stateful set, creating like a Kubernetes service, creating like the service account. If you have a security policy enabled, like addressing those things. If you think in terms of like doing those manually, those are like quite a bit of knowledge that you need to know just about Kubernetes, and also exactly how that applies to that particular database system. So those are the first pieces of challenge or sort of issues that we handle as an operator. And the other thing that I mentioned before, like if you are doing a clustering, so you cannot just depending on the database system, you cannot just use the official Docker images. You need some additional help to make sure when the pod fails over, the IP changes, those things are properly addressed, or like using some sort of leader election algorithm that is supported in Kubernetes, or some other mechanism, like it could be a combination of the support like a DNS, like SRV records, and based on the database's support, it is done. So those are the first things that we handle. And then the other thing is the automated backup and recovery. So you can do periodic backups, like you can give us a cron expression, and then you can say this is my S3 bucket, or GCS Google Cloud Storage bucket, or Azure bucket, and just take backups every 4 hours, 6 hours, you can decide. And then if the database actually supports like a automated streaming backups, setting those up, like for example in case of Postgres, you can do like a WAL file migration, so it'll continuously ship your WAL files to a remote bucket. So those kind of things we set up. And then obviously how do you recover it? So that's the another aspect of it. And recover could be just okay, bring back the old version, or it could be okay, actually clone the database. The old one that is running is actually running, that's fine, but like go to a different namespace, or maybe even go to a different Kubernetes cluster and actually recover from that backup, so I can get another copy and actually do some sort of maybe testing or analysis or whatnot, if I want to do in terms of like have a recovery in some point in time. So those kind of things we support. And then the other thing that we recently introduced was user management support. So if you, let's say you are using Postgres and you have many different databases, or Postgres, Mongo, Redis. Yeah, so the Postgres, Mongo, and MySQL. So if you want to do user management, so how do you do user management? So we actually we integrated this with Vault, the HashiCorp's Vault project. So you can use Vault project to dynamically issue like a new user for your Postgres or your MySQL or MongoDB cluster. And those users, then you can also essentially decide how much permission they have. Like you can say, oh, only grant permission on this table or that database, depending on the type of database. And then what you can do is actually the credential that gets issued, you can sort of inject that directly into some other application. Let's say you are running an API server that writes data to the database, so that can be automatically injected, and as a CSI driver, sort of the whole life cycle gets managed. So it'll actually do the kind of things that, like in a highly compliant environment requires, like okay, my database secret gets rotated every, I don't know, 24 hours or something. Like those kind of things will be possible. So that is actually already, we released it like a couple of months ago. So that's actually, we are calling that project as Cube Vault, but kind of because that could be work with KubeDB, or it could be just like you can essentially use that to manage just any general secret you have, like database secrets, your cloud provider secrets, just as a secret store. So that is another sort of like a companion project we introduced. And then one of the things that we have been doing recently is the secret management aspect, sorry, the backup and recovery that we are talking about. We are actually kind of currently going through a redesign of that aspect, which is kind of, we've been getting a lot of requests for people to sort of actually give us like a backup that is deduped and encrypted, like at rest and all those kind of things, and kind of reworking some of those aspects. So those are the sides of a database lifecycle management that we provide today as part of KubeDB.
And forgive me if you covered this already, but does KubeDB also handle any of the upgrade aspects of deploying new versions of the database, because I know that for things like Postgres, it can have some tricky pieces that you need to be able to do of deploying the new version and then migrating the format of the storage to work with the new instance. So it requires having an old version of the database to be able to run the upgrade, or for Elasticsearch, where depending on the versions that you're going between, you can either do a rolling upgrade or you might need to do a complete reindex of the data. So I'm curious how much of that overall lifecycle management KubeDB builds in.
Yeah, so this is actually one of the, I would say one of the most challenging aspect of just managing databases in general. So we are not looking to support like a major version upgrades, automatic major version upgrades. I don't think that that's really realistic, because depending on major version upgrades, even you have to rewrite some parts of your application, right? If you, especially if you are familiar with Elasticsearch, they, for every time they update their major version, they actually like change stuff like how their APIs works and all that. So that's not something we don't think they will be able to support automatically. But for minor version and the patch version upgrades, it is currently not automatically supported, but we have the sort of the, you can say the, the controls in place that you can use to manually do those changes. And we are kind of looking forward to adding those automated failover options in future releases. So changing for the patch is fairly straightforward, but like you can think of some scenarios where it kind of gets a little bit like tricky. For example, let's say you are running something like a Redis data, like a 3 node Redis cluster. So for each of the shards, one of them is sort of the primary, right? So when you fail over, what the way, what you really want to do is want to make sure the secondaries get upgraded first, and then the primary gets upgraded at the end, because that way you only need one failover. But if you just kind of do any random order, then if you kind of do the upgrade the primary first, then you have one failover, and then the one that becomes the new primary, if you upgrade that, then that gets another failover. And then the last one, the third one gets again upgraded, and that gets another failover. So you can essentially, in a worst case scenario, you end up with like a three failovers in a failover. So those, like doing those aspects of the like upgrading process intelligently, something we can do, like something we are looking forward to doing. But right now we left it to the user, like whoever is managing the database, to manually making sure that they are doing those things in correct sequence. So what we do support is that doing like a rolling upgrade. So if you do a rolling upgrade, it will not do this intelligent stuff saying that, okay, I should actually really do the primary at the end, but rather it will just go over, like if you have three pods, like pod 0, pod 1, pod 2, it will first change pod 2, then do pod 1, then pod 0. It doesn't really have any knowledge what is the correct way order to do these things. So those are not currently supported, like the intelligent upgrade process. But we're looking to do that.
And as far as being able to add support for a new database engine, I'm wondering if you can talk through what's involved in getting that set up and incorporated into KubeDB, and if there are any differences when you're working with systems that natively support clustering and therefore have an additional networking requirement, such as what you've done with Elasticsearch and MongoDB.
Yeah, so the general process is fairly similar to what you would do if you're writing like a Neo CRD and a controller for Kubernetes. So we have one project called the, like, so all our project is hosted on GitHub. So it's github.com/kubedb. So we have a sub project called API machinery, where we define all the API objects, which is the CRDs and then the auto-generated clients. So you can, the process you have to go through is essentially create new API types, the CRDs, and then run the generators to actually generate the clients, and there are some additional files that it needs to be generated. And then for the database that you want to add support for, at this point, what will be easier is to essentially just take one of the existing operators for an existing database and kind of just clone that, and kind of doing changes that you want to see for the new database version, for the new database type. So that is, and you kind of go through whatever changes you need to do. So usually around some of the stateful set, some of the services, like the what ports it uses, all that, and then the one of the important thing that you just mentioned, like what kind of clustering support the database itself comes with. So if the database needs some support from Kubernetes to do some of those clustering aspects, like using some kind of leader election or maybe some other Kubernetes API to sort of detect its peers, like it's the if you it using some sort of like a gossip algorithm, it needs to find all the peers under the same sort of Kubernetes service. So those will need some changes in how the cluster like roles or the RBACs are given, because it needs permission to kind of find out those information from Kubernetes API server. And if we actually have to add those custom components, so the way we usually do is take the Docker image. At least what we have done so far is usually take the Docker image that is available usually on Docker Hub. I think you can get like an official image or some sort of authoritative image, and add those components as part of the so as Docker image, and actually host the Docker files on the project. And once you have that, you kind of have a more or less a working, at least something that will spin up a database of that type, and clustering. So those are the first aspects, and then obviously you have to go through how all the backup recovery works, and then if you have any special like kind of that kind of streaming updates kind of features. So the benefit is right today is that because we have done all these like 60 different databases, we have enough sort of example code that you can look at and kind of essentially take from there and you reuse it. And some of the aspects is already sort of kind of flushed out as a separate library, so you can use those libraries. So that's sort of how it should go. So I would say like if you want to add a new database, you can probably get something working with a couple of weeks of work, assuming you are already familiar with just doing like a regular like a CRD and Kubernetes operator development.
And I know that there are some other projects that are available, such as Storage OS, that provide some additional facility around statefulness and maintaining storage on Kubernetes clusters. So I'm wondering if you can talk about some of the other projects that are in a similar space and how KubeDB compares to what they're offering.
So I actually looked at the Storage OS website recently, and since we last talked, I think the way I look at the Storage OS is more at the level where if you are like on AWS, they have this service, they have this EBS solution, right? Like the Elastic Block Storage. So I look at what I understood, at least looking at their website, was the Storage OS is more at that level. Like if you are familiar with something called Rook, which is for running like a safe storage cluster on Kubernetes, or cluster FS, or I think there's something called OpenEBS. Those are all sort of in the same class, where what they do is like if you are running on bare metal clusters, or I have seen that even people who are running on the cloud, they can get a like a network storage using this kind of solutions. So you kind of got like get a network file system, and then it kind of gives all the Kubernetes primitives, which is like a persistent volume, storage class, persistent volume claim, maybe some sort of CSI driver, those concepts. But they are not like really looking at the application layer. So the way it could work with KubeDB is that when you are using KubeDB and you want, like when you spin up like a Postgres database, and the each of those like the pods need their own storage solution. One of the things you can do is get a disk from AWS, or if you're on Google Cloud, from Google Cloud or Azure, whatever the cloud provider you are on. Or you could, if you are using something like an storage OS or any of the other sort of similar persistent volume, persistent storage solutions for Kubernetes, you can get a disk from those solutions and then use that as the storage volume and mount it. So if you, especially if you are on-prem, until very recently, that was probably your best bet. But usually these solutions also, like because they are network storage, they are by design somewhat slow. So if you are really like looking for really high performance, and you are on like a bare metal cluster with SSD disk and NVMe drivers and all that, then like the recent version of Kubernetes introduced like G8 the support for local volume, so where you can get really like a high performance local disk. Like it has been just released like end of the last month in March. So and if you can use that also with Kubernetes, so with KubeDB. So KubeDB is kind of agnostic in terms of how you provide the storage, as long as it is coming through as one of those like persistent volume or persistent volume claim concept that's present in Kubernetes. So that is how I would compare this kind of like a persistent storage solutions to KubeDB. So they are kind of like a one level below and can work with KubeDB based on which environment you are in. So those I would say that's how this relates. And then if you look at and if you're thinking in terms of like other sort of database operator solution for KubeDB or for Kubernetes. So there are a number of open source projects out there. If you search on GitHub, I think we are more and more we are seeing that some of the database providers themselves are providing some kind of operator based solution for running databases on Kubernetes. Sometimes those are not open source. It's kind of some they're like a closed off source offering. And then the other thing you would see that there are like a lot of projects that are built by other folks who are using Kubernetes, and they kind of can come to the same issue that okay, I need to run database, but it's not really there, or like there are like various challenges, how do I solve it? So they kind of writing their own operator. But I would say that if you think in terms of like just doing that as sort of the primary focus of the company or as a product, I don't think that there is anybody else right now who is trying to make that as a product, that like running database on Kubernetes as a product. So I would say that in that respect we are fairly unique at this time.
And as far as your experience building and maintaining this KubeDB project, what have you found to be some of the most interesting or challenging or unexpected lessons that you've encountered?
Well, the biggest challenge for us, or I think anybody who's using Kubernetes today, is that the rate of change. And it is kind of interesting is that at the same time, it is very fast. And at the same time, it is not fast enough. So if I can explain this, like, if you're looking at Kubernetes, they have a major release every 3 months. And when the release happens, it gets a bunch of new features. Like, when we started, there was no concept of, like I said, no CRD. There was just TPR. Then the CRDs came, but when the TPR to CRD changed, there was no like a live migration path. It was like a stop the world, do the migration, start over, right? So that was like a big challenge if you're running databases, because as a user, you don't care, right? Like why, like Kubernetes has this limitation today, like that had that limitation like a couple of years ago. So those are the challenges, right? And then like came this authorized like RBAC support, and then they introduced something called like a bot security policy, and all those things. As those improved, just keeping up with those challenges has been like one of the interesting one of the interesting challenges for us. I mean, and anybody who is actually like tries to write a Kubernetes operator. So that is one thing. And the other thing is, like I said, that the changes doesn't happen fast enough. Like if you are looking for some particular feature and want the way kind of the works in the upstream, which does make sense from the upstream perspective, but it kind of can take a long time, because the way it kind of goes that if you want to introduce a new feature, it first goes through this phase of like an alpha implementation. So then it goes to a beta implementation, and then it gets GA. So even I think like if even it happens the fastest path, it still takes 3 releases, which is like 9 months. So if you think if you're waiting for some particular feature that okay there's coming, but you want it or you need it, then you actually still have to wait like 6 to 9 months. I mean, in the Kubernetes world, you do not want to use any alpha feature, because when what happens with alpha feature is that there is no guarantee that it will actually go to beta, because the way alpha features are introduced is that those are by default turned off, so you have to go and change various knobs to turn it on. And if you are like you are building some product and you want that to work on any of the Kubernetes clusters out there in the wild, especially the managed services like GKE or EKS or things like that, or EKS, they do not turn on the alpha features. And especially if you are like on GKE, they actually, if you turn on like any of the alpha features, they'll delete the cluster after a month. I mean, that's, they kind of give you a big warning that this is not what production uses. So that's like one of the interesting challenges. Like, okay, I need this feature, it's coming, but it's alpha, so until it goes beta, I cannot really use it. And sometimes things going from alpha to beta can take multiple releases depending on how complex or how much other coordination or changes necessary. So that has been one of the challenges, that okay, yeah, it's coming, it's happening very fast, but it's also not fast enough in some respect. And then the other challenge, well, just doing the application development in terms of Kubernetes, is that like Kubernetes upstream projects has a, at this point, fairly well and good documentation on how to use Kubernetes as an user or another developer. But if you think in terms of where we stand, we are actually building applications for Kubernetes. At this level, the documentation quality is not really great. I mean, they have some sample projects on the upstream, and then also these things are changing quite a bit in recent terms. So if you are trying to build an application, like you are trying to write a new operator for Kubernetes for whatever purpose, like learning how to do that, like the documentation, wasn't really great. I mean, still not very great. There are various things are not very well documented, so you kind of actually have to go and read some of the source code and see how those are done for some of the upstream stuff, and maybe done by the same developers for whatever vendor they work for, maybe in that project. So kind of have to go and read docs, like the actual source code, to figure out like how this stuff. And but people are very helpful in general. So if you go to their like the upstream Kubernetes Slack and ask questions, they are very helpful. So they'll kind of tell you, but you have to spend the time to learn those things. And that has been that is like a big investment in time and resource you have to do. So those have been biggest challenges, and just keeping up with these changes.
And what do you have planned for the future of KubeDB?
Yeah, so what we are trying to do, in the near future, we had some clustering support. We are adding clustering support for MySQL and MongoDB. We're hoping to get those out fairly quickly, like in few months, hopefully this month. And then we are kind of essentially going through our like, so I think we mentioned that one thing, that that's updating the backup recovery support to have like a encrypted antidote, and like all kind of how the retention policy applies. Those are some of the key aspects. So we look at those as some of the key things for the project to reach 1.0. So those are the key things we are looking at least for the next quarter. So, and then hopefully by summer we can get to a fairly stable position where we kind of think all the things we think necessary to hit 1.0 are there. And then on the side, we are also working on some like a web console. So right now, all the things that you can do with KubeDB, it is primarily through CLI. Like they have the kubectl command line interface, and we also have like a command line tooling, which can be used as a plugin for kubectl, but it kind of also works as a separate just a standard by alone CLI tool. So we're actually building like a web interface. So if you think in terms of like how AWS RDS works, like you don't have to know all those little details about YAMLs. You have a form, you put in some of the fields, the other ones are sort of pre-filled for you, and then you get a database running. And I think that is the kind of experience we think that QDB users should have. So we are kind of working towards that. That is something we've been working on the side. Hopefully, we can get that out quickly too. And then at that point, we'll probably explore adding more database support. But until then, I don't think we're going to add any additional database support unless somebody comes along, because it's an open source project, right, on under Apache V2 license. So if somebody wants to come along and just contribute something, then we are happy to look at that. But for our team, this is sort of what we're looking at least for the next 3 to 6 months.
And are there any other aspects of KubeDB or managing databases on Kubernetes clusters or any of the other work that you're doing at Apps Code that you think we should discuss before we close out the show?
No, I think I've kind of covered all the areas. I mean, so the KubeDB, I mean, one of the interesting thing we actually have been doing recently is called a service broker integration. So if you're familiar with like a Cloud Foundry, they has in this API called like Open Service Broker. Kubernetes has a support for it via their service catalog project. So if you are on Cloud Foundry and want to run your databases on like Kubernetes and want to integrate via this service broker interface, we have a project that can do that for you. So it works fairly well with, like, if you are on Kubernetes, if your service catalog is also on Kubernetes. And then recently we have been working with SUSE they have been actually helping us to kind of integrate that into Cloud Foundry and their Cloud Foundry service. So those are some of the interesting development that's going around, and kind of this, and that is actually open source. If you go to github.com/appscode/service-broker, you can find that project, and it kind of works there. Yeah, so I think I would say there's this kind of interesting stuff that's happening around KubeDB. That's good.
And for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think the biggest gap in the data management tooling is, like if you are on cloud provider, usually you have a fairly good experience because you may be able to just use the managed services that the cloud provider offers, assuming you are, willing to take on all the, the cost and all the like some amount of vendor lock-in that comes along with that. But if you are looking at, staying some sort of, like you have a hybrid cloud situation where you have something not on the cloud, there are obviously tooling gap KubeDB tries to fill in. And the other issue I would say that, if you want to stay sort of vendor like neutral, not necessarily meaning that don't use any of the features that vendor provides, but also have that opportunity that you can move from one vendor to another, or maybe work across different vendors. There are, limitations in what you can do, because the cloud providers really usually focused on getting things working on their particular cloud, and that makes sense. So in that kind of scenario, using something like a KubeDB or the Vault and the Stash project of ours can help you to manage your data, not just the stateful applications, but just any kind of stateful data that you have managed, you can manage that.
Well, thank you very much for taking the time today to join me and discuss the work that you're doing with KubeDB and trying to simplify the work of running databases on Kubernetes clusters. It's definitely something that I've heard a lot of people talking about, and something that is not easy to do out of the box. So I appreciate your efforts on that front, and I hope you enjoy the rest of your day.
Yeah, thank you, and giving me the opportunity to talk to you and to your users, to your audience about KubeDB. And if anybody have any questions or anything, you can obviously get back to me via the contact information. Thank you. Have a good day.